So here we're going to be looking at graphing lines, and we will be looking at linear functions and linear equations. And here we see functions in the form f of x equals 3x minus 2 or y equals 3x minus 2 are called linear functions or linear equations because when you graph these, when you find all the points that make this true, they will be in the form of a line. And so looking at this form, you have your f of x equals, and then you simply have one term that has an x in it, x to the first. That's just in the numerator, like it's not x in a denominator or in a square root or anything, so just 3x to the first minus 2. So a term with x and a term with a constant. And you don't have to have the x and you don't have to have the constant necessarily. So down here we want to graph all points xy such that y equals 3x minus 2. And so to start graphing, we'll learn more about this later and other ways to do this, but we want to find these points. So as we learned before, we can make a table of x values and y values, and we'll choose several x values, let's say -2, -1, 0, 1, and 2, find their corresponding y value, and then graph those different points. So if we put -2 into this function, this is 3 times -2 minus 2. And so thinking through that, 3 times -2 is -6, minus 2 is -8. Putting -1 in here, 3 times -1 is -3, subtract 2, you get -5. Next we can put 0 in there, 3 times 0 is 0, minus 2 is -2, putting 1 in, 3 times 1 minus 2, well, that's 3 minus 2, which is 1. And then lastly, we'll put 2 in here. And we get 6 minus 2, which is 4. And so we have the point -2, -8, -1, -5, 0, -2, 1, 1, and 2, 4. And so we can graph each of these points. -2, -8 actually is off our graph. If I were to estimate, it would be about right here. -1, -5. And then we would have 0, -2. 1, 1, and 2, 4. And then you can put a line through those points to get the graph, and notice it is a line. And so we can graph a line by choosing x values and finding their corresponding y value, choose the points, and then graph each of those individual points. I mean, draw a line through those points. There is what's called a standard form of a line of linear equations, and it's ax plus by equals c, where the a, b, and c are real numbers. Another thing, we want a, b, and c not to have common fractions, to have no common factors, which is called relatively prime. So we wouldn't want like a 6, a 4, and a 10 because 2 all go into those. So we could divide both sides by 2. And if possible, we want them to be integers. If they're fractions and decimals, we can change them unless they are non-repeating decimals. So ax plus by equals c. And we want to get rid of fractions with possible, and also we want a to be positive when possible, which I don't know if I have that in here, but when our term here, a, it's nice to have the a being positive. So in this example, it just says change this to standard form. Well, standard form has an x and a y. This doesn't have an x and a y, but we already know that g of x is really the same thing as y. So what we could do is we could rewrite this as y equals -2/3 x plus 4. we notice in standard form that the x and y are on one side and then the constant is on the other side, so that's what we're going to do. So what we'll do is we'll add 2/3 x to both sides. That will allow us to have the x and the y on the left side of this equation, and then the 4, which is the constant, on the right side of the equation. And if possible, we'd rather not have fractions. And so what I mentioned before, you can multiply each side by the appropriate number. So in this case, we would multiply both sides by 3 to cancel this here. So when we multiply both sides by 3, that's really multiplying both our each term by 3 because of the distributive property. And when we multiply this out, we have the 3 and the 3 cancel, so we have 2x, y times 3 is 3y, is equal to 12, and there you have the same line, but in standard form. Well, now here we have another line that we want to graph. It's 2x minus 5y equals 10. A nice way to be able to do this is to get it in the function form, and then the reason that would be helpful is because then we have y is just equal to something, and so we can plug in x and easily find the y value. So let's take this 2x minus 5y, which is equal to 10, and we're going to solve for y because that will be easy to plug our x values in. It's not a necessity, but that's what we're going to do here. So we have negative 5y is equal to negative 2x plus 10. I like to put the x value first before the constant. And then we'll divide both sides by negative 5. As I mentioned before with multiplying, we can divide both sides by 5, but that's the same as dividing each term by 5, which gives us y equals, here we have a negative 2 over negative 5, which is a negative over negative, which is positive, and we can actually leave our x on the outside here, so 2/5 times x, and a plus 10 divided by negative 5. Well, 10 divided by negative 5 is negative 2, so this is like a negative 2. You could put plus negative 2 or just minus 2. And so here's our equation in a different form, and we're going to make a table here, and really something that we learn in geometry is to graph a line, we really only need 2 points. So when we choose our x and y, we only really need to try 2 things for x. A lot of times what we'll do is we'll do 3 just to make sure we did things right. And I'm going to choose some helpful values for x. I'm going to choose negative 5, 0, and 5. And the reason, the 0 is usually easy, but the reason I'm choosing these 5s is because when I multiply 2/5 times a 5, there will be some reducing we can do or simplifying, and then we won't have the fractions anymore. So we'll do 2/5 times negative 5 minus 2. So what we have here, 5, this is like a 5 over 1. These reduce or simplify to negative 1. 2 times negative 1 is negative 2. Minus 2 is negative 4. So we have 1 point, negative 5, negative 4. We'll go ahead and graph that now. Negative 5, so 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4 down. Putting in 0 is usually an easy thing to do because multiplying by 0 is so simple. So 2/5 times 0, which is 0, minus 2 is negative 2. So when we put 0 in, we get negative 2. And lastly, we'll put 5 in. Now, what I mentioned before, I'll come back to this 5, we really only need 2 points to graph a line. So we could graph that line. What we're doing with this third point is we're going to graph that. Hopefully it will lie right on that same line. If it doesn't, we made a mistake somewhere. We can go back and check. So 2/5 times 5 minus 2, as before, this 5 reduces or simplifies with this 5. So we really just have 2 minus 2, which is 0. So we have the point 5, 0. So we're going to go over 5, and we're not going up or down at all. So 0, and it does look like those will all lie on the same line. And so we'll graph those, our line through those points. Sometimes I miss my points here when I'm graphing the line. So I actually just make the point a little bigger. And so how many points do we need to graph a line? Just 2. But we oftentimes choose 3 just to make sure we have good accuracy. So in summary, and then we'll do a couple examples, graphing linear equations, it's helpful to solve for y, make a table of at least 3 ordered pairs. We don't really need 3, we only need 2, but we pick 3 of convenient x values, and that has to do with the denominator. Now, if there's not a fraction in there, -1, 0, and 1, or -2, 0, and 2, or something like that are a good 3 points to choose. Graph your ordered pairs, and then connect the points with a straight line. So the first thing we're going to do here is we're going to take our equation and solve it for y. So I would add 2x to both sides, and I did some things earlier in the last one, like I put the 2x first, which I prefer to do, and that will help us later, but you don't have to, so let's just see it this way, x plus 6 plus 2x. We would divide by 3 then. Again, earlier I said you could divide each term by 3, but you might not always think of that, but later it will be helpful to do that, but we're just going to leave it like this, and we'll see that it still works out. So we're going to be able to choose some points here. So we have y equals 6 plus 2x over 3. Another helpful form, if we did the steps I did before, would be 2/3 x plus 2. That's just off to the side. You don't need to know that, and you don't need to use that. But just to let you know, if you solve the same way we solved in the last one, you would get this right here. We can plug in some points for x and find our corresponding y value. We're going to go ahead and choose 3 points. And we want things that will be divisible by 3. So maybe I'll do -3, 0, and 3. If you choose -2, 0, and 2, it will work out and your line will be the same. It's just that you'll have some fractions to work with. So let's think through this. We're going to have 6 minus 2 times -3 over 3. Well, this is 6 minus 6, which is 0. 0 divided by 3 is 0. So we have a point at -3, 0. Plugging in 0, we have 6 minus 2 times 0 over 3. Well, 2 times 0 is 0, so 6 minus 0 is 0. 6 divided by 3 is 2. And so we have the point 0, 2. And so we have 2 points, and it looks like our line will go up like this. Let's plug in this 3 just to check. 6 minus 2 times 3. Oops, so this is where this helps. I made a mistake, and I'll show you where. So this is the point 3. 6 minus 6 is 0, and we have a 0 over 3, which is 0, so we have the point 3, 0. Well, obviously this doesn't make a line. We want a line, and so I'm seeing my mistake up here. I forgot to put a -3, and so this should have been a -3, so a 2 times a -3 is -6. 6 minus -6, so let's put a -6 here. That's really 6 plus 6 is 12. 12 over 3 is 4. And so this should have been -3, 4. And so we're going to erase this point down here because that was incorrect. And we can graph our line through these points, and that looks better now. We do have a line. Graph the line through those points. And there's the graph. And now you see how it can be helpful to use 3 points because you might catch mistakes, whereas if I would have just chosen 2 points, maybe I wouldn't have caught that mistake. A few more terms here. that can be helpful for graphing for sure, and we'll be using these terms throughout the rest of algebra when we're dealing with graphing, whether it's lines or other types of graphs. We have what's called the y-intercept. So that's a very important term. We'll mention that often. The y-intercept is the point where the graph intersects the y-axis. Now you can find the y-axis by plugging in 0 for x. That is very important and helpful to know. You can find the y-intercept by plugging in 0 for x into the equation that you're working with. And so we'll be doing that down here shortly. And then the x-intercept is the point where the graph crosses, and this should say the x-axis. So the y-intercept is where the point where a graph crosses the y-axis. The x-intercept is the point where the graph crosses the x-axis or intersects the x-axis, and you can find that by plugging in 0 for y. So y-intercept, you plug in 0 for x. X-intercept, you plug in 0 for y. So I have this arrow with a question here, the question why. Why do we do this part right here? Why do we plug in 0 for x? Well, let's take a look at a graph. And let's think through the points on the y-axis. So the points on the y-axis is where you might find y-intercepts. And so this point right here, this might be the point where we go left and right 0 and we go up 1. So the point is 0, 1. This one here, left to right 0 and up 2. So that point right there might be 0, 2. Let's skip a few. This is the point. It's up 5, so it's 0, 5. Or maybe we go down 1, 2, 3, 4. This is the point 0, negative 4. What is always true? What's the common bond in these 4 points and really all the points along the y-axis? Well, hopefully you notice that the x value is always 0 because whenever we're on the y-axis we don't go left or right at all. And that's why to find the y-intercept you plug in 0 for x. And so we plug in 0 in for x because every point on the y-axis so that might be tough to read. My writing is struggling here, but we plug in 0 for x because every x point on the y-axis has 0 in the x value. And then vice versa for the other one, vice versa. You plug in, when you want to find the x-intercept, you plug in 0 for y. If graphs are in standard form, as this equation is in standard form, finding the y-intercept and x-intercept are nice, easy, quick ways to graph an equation. So let's take a look at this. Let's find the y-intercept. Well, we can find the y-intercept by plugging 0 in for x. So we'll put 4 times 0 plus y equals negative 3. Obviously 4 times 0 is 0, so y equals negative 3. So our y-intercept is 0, negative 3. So I can find that y-intercept. And then the x-intercept is similar in that now you're going to put 0 in for y. So you have 4x plus 0 equals negative 3. This obviously doesn't matter, so we could divide both sides by 4. And we get x equals negative 3/4. So we put 0 in for y, and we got negative 3/4 in for x. And so negative 3/4 0 is the x-intercept. And you can then graph that line. So just by using the y-intercept and the x-intercept, you can find 2 points and draw the graph through there. And finding the y-intercept, you plug 0 in for x. To find the x-intercept, you plug 0 in for y. And that is a very important concept to know. Graph each equation and determine whether it is a function. So this is kind of a new idea. Here we have an x equals -5. In all of our other equations, we've had an x and a y, but in this one we just have an x, and in this one we just have a y. Now we're going to plug in, make a table here and plug in some points, which might seem kind of funny, but this is x is -5. So I know x is -5, so we're going to do something a little different here to help us see something. I'm going to choose some values for y. So let's say -2, 0, and 2. So looking at this equation, if y is -2, what's x? Which kind of seems like a silly question. X is always -5. So whatever point I choose for y, the x value will be -5. So graphing these, -5, 2, -5, 0, and -5, -2. We have those points, we can draw a line through them, and what do we notice about this line? Well, we notice that this is a vertical line. So when x is equal to a number, just x equals some constant, it will be a vertical line through that number. So really what you do, since it's an x, you find -5 on the x-axis and a vertical line goes through there. This is not a function because it doesn't pass the vertical line test. Now we can do a couple things for this next one. Since this was x equals -5 and it was a vertical line, y equals 3, you might be able to conjecture and think what type of line that would be. So maybe you're thinking of that now, but we're still going to make a table. We have x and y. I'm going to just choose some values for x. When x is -2, what's y? Well, y is always 3, so no matter what value I choose for x, I always get 3 for y. So -2, 3. Sorry, that's +2. -2, 3, 0, 3, and 2, 3. We get a horizontal line. And maybe that's what you thought would happen. And so when we have y equals a number, that's going to be a horizontal line going through whatever number this is. And yes, this is a function. Because it passes the vertical line test. So we see here horizontal and vertical lines. Horizontal lines are in the form y equals a. So y is equal to a number. They are functions. Vertical lines are in the form x equals a number, and they are not functions. And so that's our introduction to lines. We'll be using more those concepts, especially the x-intercepts, y-intercepts, horizontal lines and vertical lines will come up later. Well, all the stuff really. So that is graphing lines.